This is Psychology 7540, Statistics, and today I'm going to talk about hypothesis testing. So previously I talked about descriptive statistics. Hypothesis testing involves inferential statistics. So hypothesis testing involves taking a sample, taking a group of people, and using that sample to make inferences about a larger population. Now, when you think about studies you've read, no one is particularly interested in just the group of people that participated in the study. What you're interested in is what those people say about people in general, or say about the population that they were taken from. So you might have 50 psychiatric patients. Well, it's interesting to know about psychiatric patients in general, but those particular 50 people, we aren't particularly interested in knowing about them in particular for the purpose of the study. So let's go through the steps of a typical psychological research study. Let's say we come up with a new treatment for depression. It's called finger activation treatment. So it has something to do with tapping your finger in order to reduce depression. And let's compare that treatment to people who are on a waiting list. So we have finger activation treatment, FAT, and we have waiting list, WL. So we randomly assign people to either the FAT group, the FAT group, or the waiting list group. So they call in for this experiment. We're paying them a certain amount to participate. We flip a coin to decide which group they're going to be in. So they go through the treatment, and then at the end of 6 weeks, they take the Beck Depression Inventory. So the lower your score on the Beck Depression Inventory, the less depressed you are, the better you're doing. So our experimental hypothesis is that people who go through FAT are going to end up with lower Beck scores than people who are just on the waiting list, than people who don't get the treatment. Now, this is the way that we reason in a research study when we're doing inferential statistics. We aren't going to directly test that hypothesis. What we're going to test is an alternative null hypothesis. So what we're going to say is, okay, for the purpose of this study, let's start out with a hypothesis that our new treatment doesn't work. For the sake of argument, we're going to say that the people who go through finger activation treatment are going to end up equally depressed or maybe even more depressed than people on the waiting list. In other words, our null hypothesis is that our treatment is ineffective, and then we're going to see if we can gather enough evidence that that hypothesis, that null hypothesis, becomes implausible. Now, let me make the point that these hypotheses aren't about our sample, they're about the population of depressed people that our samples were drawn from. So we might get the people in our FAT group a point lower on the Beck than the people in our waiting list group. Well, that doesn't really demonstrate that our treatment worked. It would only demonstrate that our treatment works if the difference is large enough that we're convinced we can generalize it to the population. So we run our experiment for 6 weeks. At the end of 6 weeks, the Beck scores for people in the finger activation treatment group are 10. The Beck scores for the waiting list group are 14. So we start out assuming the null hypothesis. The population of people with depression would, after 6 weeks of FAT, be no less depressed than after 6 weeks of being on the waiting list. Second, we say, now what's the probability of getting these results with our sample if the null hypothesis is true for the population? So if everyone in the whole country, or everyone who's depressed in the whole country, went through our new treatment, would they do better than everyone in the whole country being on a waiting list. So just from our sample, we're able to come up with a probabilistic statement. We're able to say what the chances are of there being no difference in the population. If the chances are so small as to be implausible, then we'll reject our null hypothesis and we'll say that our treatment worked. And for statistical purposes, the convention is a significance level, sometimes that's called the alpha level, of 0.05. So we'll say if the probability is less than 5% that our population FAT is no less depressed than our population waiting list group, then we'll reject the null hypothesis and we'll accept the experimental hypothesis. We'll say that our treatment worked. So that's the basis of all inferential statistics. You start out with an hypothesis. You say, for the purpose of argument, we'll say that our hypothesis is untrue. You collect information, and if after collecting your information, your null hypothesis becomes implausible, then you reject it and you accept your experimental hypothesis. You say that your experiment worked.